the weather is shitty and this is a really packed room, like amazing work coming on here. I myself am coming in from San Francisco and a little bit nervous to give this talk, to be honest with you. And the reason why is because Spark 4.1 has a lot of new features, and I think relative to a lot of this room, I'm probably kind of a Spark novice. Like, it sounds like there's some people here who've been working with Spark for a really long time, and I myself still consider myself learning a little bit. So I want this to be a little bit less of, I'm this expert and I'm telling you what is right and what is wrong, and more so, Spark 4.1 has a lot of really cool new stuff. I spent some time learning this, and I want to share my learnings with you, and let's brainstorm how much we actually like it. So I just want to reframe it that way because I don't want to frame it any other way, to be honest. A little bit about me. Like mentioned, I'm a staff developer at Databricks. I spent quite a bit of time in the open source communities, Apache, LFA9 data, mostly on sort of like this data ops side. So my background is traditionally in open table formats and catalogs, actually. So getting to jump into the query world is really exciting for me, especially working with engines and one as mature as Spark. But there's a new ecosystem that's kind of jumping up, and I think the space is really evolving quite quickly. So let's talk a little bit about what I'm going to be talking about today, which is this new thing called Spark Declarative Pipelines. It's a new framework that's been introduced in Spark 4.1, which is kind of interesting because new frameworks like this are usually in the major releases and not the minor releases. But Spark is a very mature project, and there's a lot of things that happen in every single release, so I think it makes sense. And today we're going to be talking about why maybe we might be interested in shifting from imperatively coded pipelines to declaratively coded pipelines and what that looks like. So maybe some of the reasons why we might switch this syntax, but what does that syntax actually look like? What are these sort of things that we're interacting with as developers, and then also what it looks like to deploy a pipeline and actually get started with SDP. So let's start by framing what SDP actually is, which I'm going to use as the abbreviation for Spark Declarative Pipelines. So Spark Declarative Pipelines is a new declarative framework that sits on top of your core Spark library. So underneath is still Spark Streaming, underneath Spark SQL, PySpark, and it has full API compatibility with Python and SQL. So everything under the hood operates as you would expect it to, just on top now. There's a framework that you can use to write pipelines in a different way, which we'll get into in a little bit. So why shift from imperative to declarative? So there's a lot that's been talked today about FinOps and how do we manage these large-scale pipelines and how do we manage all these query logics. But declarative pipelining has been around for a very long time, especially in these large distributed systems. A really good example of this that we see in sort of this trend as data engineering catches up with software engineering is how do we actually manage resources, right? So some declarative frameworks that you're likely already using include Kubernetes, you're managing all these different containers, but you're not actually figuring out which resources belong for which container, and you're just instead telling Kubernetes what you want, and then Kubernetes figures it out in terms of state. The next is Terraform, right? So we have a configuration file that we use with Terraform, and then we want to define which IAM policy we want to apply, which sort of different infrastructure pieces that we want within our infrastructure as code, and then we just kind of assume that Terraform is going to handle it instead of us, right? And I think as data engineers, we're trying not to become infrastructure engineers too much. So these are hopefully tools that feel a little bit more familiar. Another common tool in the data engineering world that we'll see here is Apache Airflow, right? We define our DAG, and then the tasks can trigger from each other, but we're not actually manually trying to orchestrate it, and we're like hoping that Airflow does some of that work for us. But there are some things that Spark does do that is declarative, so this is also not new. I consider SQL to be very declarative. The concept of a data frame itself is very declarative. I'm not writing a data frame and then going into the query plan itself with Spark and then identifying exactly what it's going to do. Some people might want to do that, not me. I'm lazy, remember that. And so
Spark is also lazy.
Spark and I have a lot in common in that way. So there's this gap here between Airflow and I think the sort of API that we've dictated for query engines to abstract away a lot of that logic, right? Airflow is fantastic, but Airflow doesn't actually have much insight into Spark jobs themselves. right? This is a big pain point when you're actually, orchestrating many different Spark jobs like Airflow. So again, if we want to talk about imperative versus declarative, when we talk about imperative code, we're really defining, exactly when we want executed, in what order, we're defining the retries, we're saving all these intermediate data frames, and then we're saving and then, trying to pray for the best, right? If we're declaring something, we're declaring what maybe a data set we want to look like is, perhaps even the data model, and then we're assuming in this case that Spark will figure out how to get there on its own. This is really the shift that we're looking at, and so Spark has always been kind of declarative. I think a lot of things are quite declarative as they obscure more from the user, but of course there's a lot about Spark that isn't declarative. In this case, if I were to take a simple pipeline, let's say we have two sources here that are feeding into a table called backorders with the Spark SQL syntax for declarative pipelines. We're hoping that ideally this is the only code that we look at, right? Like we're just taking a couple views and then we're dumping them into the same table. And this is really straightforward. Like I would hope that this is all that I really want to concentrate on as a data engineer. Realistically, I have to write all the code that does this. Right? Like I have to figure out what is the sequence of the different transformations I want to be executed in. If I end up doing some sort of parallelization, I might have to create a thread pool, and then I'll actually have to define how that actually gets parallelized. If, let's say I'm reading from a Kafka topic and Kafka service goes down, I have to then figure out how to retry that job, right? I have to actually figure that out in my code somewhere in my pipeline. If there is a schema mismatch, that might be an error that shows up very late into my pipeline, and I won't figure it out right away, so I have to write some code in there to do the error handling. And then of course, if I want to update or work with perhaps a subset of my data set that is only within the pipeline itself, it doesn't necessarily affect the entire pipeline, it doesn't matter, I still have to rerun the entire thing. So very annoying, all of this stuff. And in theory, we want to just concentrate on this, right? So that's kind of what SDP was built around the idea of, is how do we obscure a lot of this infrastructure management from the actual user itself, at least to lower the barrier of entry a little bit when it comes to deploying and managing Spark. So let's say in this case, we define what the tables are that should exist in this case, and then SDP will ideally figure out the retry logic, the parallelization, the sequencing and order that everything should be in, and build the dependency graph itself without me having to keep the dependencies in my head and then figuring out reading hours into a run. So this is kind of a trend too in terms of how we think about shifting left in terms of how we actually want to identify a lot of these error messages and catch them early before we hit run. So in imperative syntax, there's a lot of room for error there for actual errors to be caught quite late, depending on which step the error is in. And there's no way to really validate whether or not a run that you're going to have is going to be quite smooth, right? Maybe there's some dependency errors that you don't necessarily know. So what SDP will do in this case is actually scan all the queries that you have and all the data sets that you've defined, and then infer the dependencies between itself, between the upstream and downstream tables. And then using the option of dry run, it's actually going to see whether or not there's any dependencies in there that are mismatched within its backend graph. With dry run, you're actually not processing or touching any data, and so instead you get to see right away, right as you're executing, or whether or not you're doing dry run, if there's anything that's missing there, any errors that might occur. So we'll get into this a little bit more later. What I'm going to be talking about really quickly is what SDP actually looks like. So there's a couple different targets that you'll have with SDP. The first is data sets, which you'll have tables and views of. And the second are sinks, which, if you write a lot of structured streaming queries, you'll know that a sink is sort of like this catch-all use case that you can use to say maybe write to another Kafka topic. And then this idea of flow, which is really implicit when you're working with declarative pipelines, but has the option to be more explicit. And a flow is really this sort of unit of you considering what is my source, what is my transformation, and what is my target, if I were to group them conceptually into a single unit. So let's go into the data sets in SDP and what you'll find. So SDP has Python and SQL APIs, but if you're using Python, you're going to be using the decorator syntax, which we see here. And in this case, oftentimes, if you're using SDP, it will be in the PySpark library with the declarative pipelines module, which oftentimes is abbreviated as DP. So that's why you'll see dp.table, things like that. So the first one on this list that we'll go into is a streaming table. So a streaming table typically is when you're working with a structured streaming query that ingests from some sort of streaming source. But what makes a streaming table kind of interesting is that it incrementally processes data. So if you have data in there, it's going to refresh and only process the new data that's coming in that's been in the source versus all that old data. There's some trickiness to this, but generally speaking, if you know what you're doing, this can be really cool in terms of saving, I guess, money. Sounds like people here really care about saving money. The next is a materialized view. So this is when you're working with, say, a single batch query, and you're ingesting from some sort of table, some sort of source like that, and you want to have a pre-computed view that then you can access outside of the pipeline, and it's computed all at once every single time you run the pipeline, which can be kind of annoying because then you're rerunning all your input data, but is also really great because then you have a materialized view that you can actually work with. Temporary view is scoped to just the pipeline. So this isn't really meant to be interacted with outside of the pipeline scope, but it's useful for building the dependency graph, but also because sometimes it might be useful to reuse different components of a view in other different flows that we'll talk about later. And then you have your normal view. This is, of course, a SQL thing where you're just scoped to the actual pipeline logic, and it's just like being stored in memory. Okay. So let's go into the syntax again. In this case, we're going to create a materialized view that you see up there. In this case, it's going to be default named to the function that we're working with, which is events. And then we're using the PySpark package. So really simple, basic logic just to make sure that we get the structure right. And then it's going to read from a table called raw events. If we're using a streaming table, we might want to read from the stream. So if you're used to structured streaming, this is probably not too different for you. The key thing I would note here is how equivalent the SQL and the Python syntax is. Like, I think it's pretty intuitive to catch. But of course, if you're working with streaming table, you're often working with like really large, like raw data. So if you're using this mostly in sort of your bronze layer versus like, I want a really polished table that I can fit into a dashboard, for instance. And so of course, again, this really involves incremental processing. So you're only processing new data as it's coming in each time. But there can also be caveats to that, though, depending on if your logic is up to date or not. So if you're changing the logic, the new rows that are populated and appended may only contain that new logic. We'll talk into how you might be able to mitigate that later, but generally this is what you're working with. And if you're used to structured streaming and you're used to managing checkpoints and cursors and networks and things like that, SDP will handle the checkpoints for you, which is really cool. The second is a materialized view. So if we're working with a materialized view, again, we're working typically with a batch use case, where we want this data to be structured. And then really, this is something that's going to persist outside of your pipeline run, so that you can then access this and use it to populate whatever else you need it to, or feed into whatever else application that you might need. So this is typically in a more polished use case where you kind of know you always need this data to be computed at some point, and that's going to be accessed quite widely, typically in like a silver or gold layer if you do that, and then it's always going to be available as a queryable table. Okay. So why use a materialized view over a streaming view? Well, a materialized view is really nice because you get, really straightforward use case there. You don't have to manage the actual long-running table that you might have with all these different appends. So for instance, if I'm running a streaming table, and the first 90 rows are a certain, type of logic that I wrote with this streaming table function, and then I decide to change it later, only the new rows are going to be changed, right? This can cause issues, but I think that's just the reality of it. You can run a refresh in this case to update the entire input data, but again, that's sort of the downside of material views as well, is that you're computing all of the input data every single time you run this, and it's populated at run versus at read, which is what a normal view typically does. But your code changes will reflect more immediately, and it's a little bit easier to track your code when it changes there, right? And it's very simple, it's very predictable in terms of what you're working with compared to a streaming view. For data sets, again, there are normal views here, and typically this is going to be just where you're using to track your actual pipeline logic or your query logic here. And this is just a basic view in scope to SQL only, because that's how Spark works. And yeah, I think that I don't have to explain views too much here. And then there's temporary views. So temporary views are these intermediate views that are not necessarily going to be saved or persisted anywhere, but generally speaking, they are accessible for the pipeline components, and they're accessible for SDP to be able to infer the dependency graph, but also you can use it for testing. You can use it in reference to other flows or other data sets, whatever you write within that single pipeline. So let's say I have a particular piece of logic, particular table that I want to reuse for future things. That's a really good case for a temporary view as well. And it makes, again, the transformations much more reusable, right? And these are things that can be tracked, which is really cool. Next is the concept of a sink. So a sink is, again, just sort of like this, whatever you want it to be, but typically just using it to write to another Kafka topic so that you don't have to keep it anywhere. And generally speaking, it's just sort of like this multi-purpose use system that you want if you're using streaming. I won't get into too much, but you can define sinks as well in SDP, just like anywhere else. So let's get into this idea or concept of a flow. So a flow, like I said, let's think about it in sort of this three-piece way where we have our source, we have our logic, and then we have our target. This is like the flow of data, literally. And it sounds really fancy, but I think you can use it pretty interchangeably with query. We do make the distinction in it with SDP. So you can see at the bottom here that the actual code that we've written here defines a streaming table on its own, but then we actually create a flow explicitly. So flows are typically implicit within SDP. So if you're using SDP, you're not going to directly interact with flows all that much, but you might see in your logs that there's all this terminology like created flow and did this with flow and flow this and flow that, and you might just be like, where did this come from? What the hell is a flow? You can explicitly create flows. This is really useful if you're, again, using sinks and you're streaming different tables to each other, but also if you're working with multiple flows, right? You might have one single target that then you bring multiple flows into, in this case, multiple streaming tables, which gives us this example, a very stripped down, easy example. Hopefully you can digest this quickly. But generally speaking, if I identify a streaming table, I can then append flows to that one single streaming table from different streaming sources, whatever you want. You can also use cloud files here in JSON format, whatever works for you. And then this is the idea of having multiple flows in one single place. So I move forward here. When we have multiple flows, and when we consider this sort of mindset shift, we can create then the dependency graphs that SDP does to identify what our different places are. And we'll get into this a little bit more later, but you can see with the different notes here, we have our sources and we have our actual views and where they're actually going to it. So let's talk about the SDP project structure. So the SDP project that you create, very easy, like let's say we've created a bunch of different files that look like this or much more complicated, because I imagine you guys write much more complicated jobs. We have all these Python files, but SDP doesn't actually run it just through whatever scripts that you give it. Instead, you kind of need an SDP project structure for SDP to be able to interpret. And so if you run an init, which is through the CLI tool, it's going to populate a directory with your configuration file, which is your pipeline.yaml, transformations directory for you to store all of your logic in. And I don't think it generates README, but you should always keep README anyways. That's good practice. And then whenever you're running this afterwards, SDP is going to use Spark to run the steps. And so if you're looking at the actual configuration file, it's pretty basic. You have the name of your pipeline, You have the paths to all of your Python scripts or your SQL scripts. There's an optional catalog configuration, etc. And so you can, there's probably a lot more that will be added in the future, but it's pretty bare bones and basic, which I think is good for starting. And then after you have your configuration set, you can then run the actual pipeline, just again using the CLI. Dry run is what I mentioned, where you want to actually catch any dependency errors. Oftentimes syntax errors are caught in this as well, whatever source errors, typos, and things like that, before you actually commit to a full execution, right? And you can do this locally, which is really awesome. You don't necessarily have to have a whole setup. And then you can actually run the pipeline if you want to, or you can run with a specific configuration file, whatever folks you wrote. And so if you're going to develop with SDP, this is really nice because you can catch errors early in your logic. You can catch them frequently, which is really cool. Because you're not actually touching the data itself, you're transforming the data. And so it's quite quick to iterate on this compared to typical imperative development. So if we look at what a pipeline runner graph looks like, we have our logic here. And then we also have the dependency graph that has been generated on the right side. There isn't like an inherent way in Spark UI to generate this graph currently. There are some really cool VS Code extensions that will allow you to do this though, which is really awesome. But you can sort of map here how some of that logic translates into this graph. If you are interested in parallelizing your code, typically what you would do is, again, manually start the start pool and then add in that parallelization code. But with SDP, as long as flows don't have dependencies on each other, it's just going to automatically parallelize that for you. So then it's going to run, which is really nice because then you don't have to manually manage the threads. You don't have to configure the parallel execution yourself. It's kind of just magic. I hate saying that, but it's like, I think if you're just an intermediate developer in Spark, like this is something that you don't want to think about, right? Like if you're edging for the best performance or things like that, you might want to manually go in there. But generally speaking, like I think this is very much an easier way to get started. And so this is another example of that where you might have multiple flows that again have no dependencies on each other, and then SDP will join them when they're all complete, but also parallelize them for you. Another option that you may have is to do a refresh. So when we refresh in our SDP pipelines, one of the things that we can do is refresh all of the tables and repopulate them, whether or not they're material views or streaming tables. Again, if we're working with streaming tables, it might be useful to just refresh that particular streaming table, and we have partial options for this, like the selection. And this is because maybe we've changed the logic for streaming tables, something like that. We want to just refresh the entire thing. And then, of course, we have the full nuclear option in there, full refresh all. I'm going to go through a really quick demo. It's very fast. The editor was like, she's going to talk really quickly through this. So I'm going to see if I can pause or go back on this. But essentially, let's see. Can you do that?
You can tell.
Yeah, maybe.
You can do this.
Yeah, change the speed.
Let's see. Let's go here. Let's go 5. Okay. Now we're going to be going through this really slowly. This is just a Docker container with Spark 4.1. We're going to spend like 30 seconds on this. And then we're going to init a new pipeline project called My Pipeline because I'm very inventive. I am super creative. And then we're going to, let's see. Yeah, I think it's just printing out whatever files are generated in that directory to ensure that the pipeline was, in fact, populated, which you can see here. We have our configuration file, we have our transformations directory, and then we're going to actually, I think it's just adding the configuration file so that we see what's in there. But this is on my own PC, to be honest. Yeah, and then we can see what's in there. So it's just our transformations path. And here is where it's maybe a little bit more interesting, where I wrote a really simple sales pipeline that adjusts from a Kafka topic, as well as a Kafka source, as well as creates a materialized view from iceberg tables. I don't think you need to really look too deeply into this, but it's just reading the stream from Kafka. And then once again, with syntax highlighting, because I think I realized midway that people don't want to look at just your code. Then we have our materialized view that's created here from our data and ingesting straight from Iceberg. And then I'm going to dry run this, and it's going to be perfect because my code is perfect. Nothing ever poor happens to my code, and remember that in 30 seconds. So we can see if we do a dry run here and through the logs, it's a little bit more digestible than normal Spark logs, I'd say. But you can see that it actually creates the data flow graph, it registers the graph elements, and then it runs, and then it says the run is completed. So it's pretty smooth. What if something goes wrong? Because that is the story of my life. We're going to do this a little bit slower. Ooh. Okay. As you can see, very indicative. Oh, yeah, indicative by the actual pipeline. I'm giving it a broken pipeline that is meant to be broken. And it is the exact same code, exact same tables, but I make a really simple error here, which is that I accidentally name one of the tables poorly. You're going to see that in a second. Maybe I made it too small. But we're going to dry run this. I don't know if you guys caught that, but let me make sure that you did. Whoops. Sorry, this is like the messiest demo I've ever done. Okay. I think I'll be fine. Okay, so you can see here, there's just a Z instead of an S, right? That's it. There's really nothing else I wanted to show you there. Then if we hit dry run now, because that dependency doesn't exist and it's actually syntax error, we're going to see if it catches it. And it does. So I'm going to highlight this in a second. But it actually raises the error and it catches it right down to what the error was, which was the orchis type, which is really cool. So how does this work with something like Airflow, for instance? So Airflow orchestrates on the application layer, and I think it should stay that way. Like, I don't think Airflow should be up in Spark's business or any other query engines, but it can be a pain because most people use Spark with Airflow to orchestrate the job. So typically in the setup, you're orchestrating multiple Spark jobs, but you don't really have insight into the actual pipeline logic. So now, instead of doing that, you can just have it orchestrate one job, which contains an SDP pipeline, and then SDP will orchestrate within itself and then allow Airflow to stay in its lane, which I think is the better way to operate and the cleaner way to operate so that then you can look at the logs from either. And how does this differ from other pieces in the ecosystem? I think DBT is a really common example of like, why would I use this? I have DBT. It depends, are you a Spark user? Like, I think that's really the distinction there. SDP has a lot of bash and streaming capabilities, but I don't see the reason to have a super hard distinction if you want to. And of course, Airflow versus SDP, we've talked about already. So, now available in Spark 4.1. I'm not a salesperson, this is open source, so it's all free. Can't sell free things that well. But there are a lot of other really cool updates in 4.1, including RTM, which is real-time mode, SQL scripting enhancements, PySpark UDFs and things like that. So definitely do check it out in the release notes. If you're interested in developing with SDP, this is a QR code that will go directly to the docs for the declarative programming guide. And yeah, that's kind of it.
Thanks. Was super interesting. Also time for the questions. Yeah, Jack.
Hello, thanks. That was great. I have luckily enough been evaluating using SDP at my company recently, and one of the things that I'm having trouble getting my mind around is we use a lot of bash stuff, and we want to have bash pipelines with SDP, but have just like normal Delta tables. We're doing this on Databricks, and like with the materialized views, you don't get the like change data feed or like time travel or stuff like that. am I just like thinking about SDP wrong? Like, can you convince me that I don't need those things, or what? I don't know. That's my question.
So unfortunately, like CDC right now is kind of a platforming type feature, and there may be things that eventually come into the community, and that sort of feedback helps it a lot. I can't say more than that, but
All right.
definitely validating your concerns. for
Cool.
Sure. Yes.
Thanks.
Any other questions?
Just very quick, so basically does SDP, SDP support all of the Spark basically supported engines and sources of data, or is it like coming with more support as we speak?
It's still evolving with more support right now. So right now, anything that's involved in structured streaming is supported, and most of the batch ingestion. But I think there's still a lot of ground to cover still.
Oh, so I have last question. I'll make it 3. I'm curious if you're familiar with some benchmarks. So people did in open source or maybe Databricks, comparing, let's say, TPCDS or something on, writing Spark SQL versus SDP.
Ooh. It kind of sounds like a DataFlint job, am
No, I'm curious because I like performance. So
No, I agree.
if not, we're gonna do it.
I think there's a lot that's been done on the official Databricks channels, because this used to be like Delta Live tables, and then now it's Spark Declarative Pipelines that lives on platform and in the open source. And so if you trust those benchmarks, sure, but also it's on Databricks, right? So how much are you going to really trust it? When it comes to pure open source, I'm not currently aware of those benchmarks, but it sounds like a great opportunity.
Yeah, that's it.
Yeah.
Cool. So thank you very much, Lisa. And everyone, we have time for mingling and chatting. If you have more questions to the speakers.